Chapter 3, ZONAIR Input Data Structure. If you want to run ZONAIR in the folder where the input file resides, you type ZONAIR and input file name and output file name. However, the output file name is optional, and if you don't specify the output name, for example, you type ZONAIR myjob.np, and the default would be myjob.out. When ZONAIR job finished without any error, and you will hear one beep. If ZONAIR encounters some errors, and you will hear two beeps. If you don't want to hear beep, you say ZONAIR notify equals no, then you will not hear beep. To run ZONAIR, of course, you need an input file, and in case you want to perform flexible error elastic analysis, and you have to import the structural finite element solution, and in this case, you have to use the assign FEM equals executive control command to import the structural finite element solutions into ZONAIR. And you have another file name called dirname.fix. It specifies the path name where the runtime database files are executed. And when you install ZONAIR, the ZONAIR installation will automatically set up this file for you. Of course, you need a ZLS server, and then you run ZONAIR. And ZONAIR will automatically set up a runtime database to store the data entities generated by each module of ZONAIR. And then you can save the aerodynamic influence coefficient matrix AIC or retrieve the AIC. And the output file contains all the output information. We call this a standard output file. And ZONAIR will generate another log file, say myjob.log. It documents the CPU time of each module in ZONAIR. ZONAIR can also generate some plot files. For example, you can look at the aerodynamic model and look at the pressure distribution, and also you can display the deformed aerodynamic model, and also you can display the interpolate motion by the spline module. When you install ZONAIR, you have to have a SIGNET dongle. Then you have to attach this dongle to the server, and once you have a dongle on the server, and when you run ZONAIR, and ZONAIR will go into the server to check out a token. After ZONAIR finish the job, you will release back the token to the server. But sometimes if you have an abnormal termination, for example, you have a power failure, and then you will have so-called lock token problem. And also when you want to kill a ZONAIR job, the best way to kill a ZONAIR job is go into the task manager. You select the ZONAIR bin.exe, and you end the job. You don't want to select the ZONAIR .exe. Another way to kill a ZONAIR job is to type Control-C, and in this case, ZONAIR can release back the token to the ZLS. However, if you are running a ZONAIR job in a folder, and then if you close this window, you will have a lock token problem. So once you have a lock token problem, you can go into this folder, ZLS and log. In this folder, we provide you a cleanup.exe on Windows and cleanup on Linux. If you run this program, you can release the lock token. However, if the token file was not properly written, this cleanup.exe won't work. If the cleanup.exe cannot release the lock token, you can restart the ZLS server. However, when you restart the ZLS server, all the ZONAIR software jobs while they are running will be killed. Okay. The input data structure of ZONAIR consists of 3 sections. The first we call executive control sections, and the second one we call case control section. The third one we call bulk data section. This is very similar to NetStran. And this is all the available executive control commands in the executive control section. The only required command is called CEND. And so this command ends the executive control section. This is a typical example of an executive control section. If you specify solution 1, and that means you want to perform static error elastic analysis. In this case, you have to import the structural finite element solution using the assign FEM equals executive control command. And if you want to import a matrix into ZONAIR, and then you have to use the assign FEM equals executive control command. If the executive control command exists 80 columns, and then you ending a comment here, then ZONAIR realize that there's a continuation command followed by this command. A solution, you say solution and followed by an integer. This integer, you have 3 options. If it's specified 0, that means you don't want to import any structural finite element solution. Therefore, the aerodynamic result is for the rigid aerodynamic model. And you say solution 1, that means you want to perform static aeroelastic analysis. Now, in this case, you have to import the structural finite element solution using the assign FEM equals executive control command. If you say solution -1, that means you want to stop the program execution after the aerodynamic panel model is generated. And in this case, you can use the plot error count to look at the aerodynamic panel model. If you specify solution 1, then you have to specify assign FEM equals executive control command. And because the structural finite element model, if it's a half-span model, this half-span model can generate a symmetric mode and anti-symmetric modes. If you have a full-span model and you only generate asymmetric structural solutions, so you say assign FEM equals A. This A is the finite element solver output file name, and form B, you specify what kind of a finite element solver you use. For example, you can specify MSC, and that means MSC NetStran or NX NetStran or ANSYS or Abacus or ideas, so on. And the boundary, you specify what kind of a boundary condition of the structure model, and then you can say support ASAP. Okay, and if you run NetStran, you have to use the solution 103, and then you have to say echo equals sort or both. And if you say ASAP equals yes, and then in the NetStran you have to say S vector equals all. If ASAP equals no, which is default, you have to say displacement equals all. And the ZONAIR requires the following information from the structure output file. It needs a grid, it needs a coordinate transformations, natural frequencies, generous mass and the stiffness matrices, and the motions. So this is the typical NetStran output file from the solution 103, and then you have to say echo equal to sort, displacement equal to all, and then NATRAN will echo the input file, and then followed by the eigenvalue, natural frequencies, and the generalized mass and generalized stiffness, then followed by all the mode shapes. So if you have a half-span structure model, you can generate so-called symmetric modes and anti-symmetric modes. So you can say boundary equals to sim and boundary equals anti. For the full span structure model, you have to say boundary equals asim. If you say aset equals yes, that means NATRAN will output the structure mode only at aset degrees of freedom, and then in the NATRAN input file, you have to say S vector equal to all. So it will output the mode shape at aset degrees of freedom. Support is to specify the degrees of freedom of the rigid body modes of the finite element model. The integer represents the component number of the rigid body mode, and say if you say support equals 135, that means you have a 4.5 mode, and the plunging mode and the pitch mode for the symmetric rigid body mode. If you say support equals 1, 2, 3, 4, 5, 6, then that means you have 6 rigid body modes. If the integer is a negative, say you say support equal to negative 1, 2, 3, 4, 5, 6, ZONAIR will perform the following tests. First, because the Lanczos eigensolver, when they solve the rigid body mode, and it is not a pure rigid body mode, and also is in the principal axis. So if you specify a negative integer, ZONAIR will replace the NATRAN compute or the finite element compute rigid body modes by the program internally generated rigid body mode, and this internally generated rigid body modes are in the body axis. And the rotation center, for example, for the pitch mode and yaw mode, the rotation center of this internally generated rigid body mode is defined by the REFX, REFY, REFZ in the AEROGEN. Yeah. And also the Lanczos computed natural frequency for the rigid body modes sometimes is not 0. It's a small number. If you put a negative sign of the support, and 0 will force those natural frequencies and generalized stiffness of the rigid body modes to be 0. Also, the support degree freedom is defined in the NATRAN local coordinate. And sometimes you want to import a matrix into ZONAIR. This matrix must be written in the output format. Okay, so this is a typical output format of a matrix. So you specify a sign matrix equals a file name, and then you have to give a name of the matrix. For example, you have to give if you want to calculate the inertial load. For example, in the trim module, you want to calculate the inertial load, and then you have to import the MGG matrix. So you say mname equals mgg, and then this file contains the mgg, the GSAT mass matrix, and the format. If format equals to format, that means that this output form is written in non-sparse and ASCII file with the E16.9 format. If you say format 23 is for non-sparse and ASCII with 23.16 format. If you say unform is for binary format. If you say S format is for sparse and ASCII format. CPU defines the number of processors for parallel computation using OpenMP. All the matrix operation in ZONAIR And for example, if we want to perform matrix A times matrix B equal to matrix C, and during this matrix multiplication, and if you have a multiple CPUs, you will increase the computational speed. However, if you specify a lot of CPU, the efficiency deteriorates. Double, you want to convert the entire computation from single precision to double precision on a 32-bit computer. Today, we only release the 64-bit ZONAIR version, so you don't have to specify double. And this is all the case control commands available in the case control section. The required command first is called begin book. This to end the case control section, and you have to have a subcase, and within each subcase, and you can specify a discipline. The discipline of ZONAIR, including the AEROGEN to invoke the aerodynamic analysis, and FLEXLD to compute the aerodynamic loads of flexible aircraft, and GENBASE to generate an aerodynamic database, and GIGCP is to correct the pressure distribution from the cruise ship to the JIGCP, and JIGCP determines the JIGCP, and you can specify echo. That means you want ZONAIR to print out the input file, and the title you can the title describes the job by a character string, and then you have to say you can use subtitle. Subtitle is within a subcase. Oh, by the way, trim is another discipline you can specify within each subcase. So once you define the aerodynamic panel model, and then ZONAIR will generate the AIC matrix. And if you want to compute the flexible loads, and you have to specify assign FEM equals to import the structural finite element solution, then you have to specify solution 1. Then you will invoke the spline module to interpolate or spline the mode shapes from the structure grid to the aerodynamic model. You can look at the structure panel model using the plot error card, and then ZONAIR computes the CP and the aerodynamic force and moment coefficients, and you can use the plot CP card to look at the CP distribution. And ZONAIR can perform the aero heating analysis, and you can perform trim analysis. And you can use the plot trim card to look at the deformed aerodynamic model under the trim loads. And the spline module can output the spline mode shape on the aerodynamic model. You can look at those mode shape on the aerodynamic model using the plot mode card. AEROGEN invokes the aerodynamic analysis discipline on the rigid aircraft. So you specify AEROGEN equals an integer. For example, equals 100. In this case, you have to have an AEROGEN Bogota car in the Bogota car section with the ID 100, and the AEROGEN must be located in one subcase. Begin book to specify the end of the case control section and the beginning of the bulk data section. So this is a required case control command. And FLEXLD, you just like the AEROGEN, but this time you want to calculate the aerodynamic loads on the flexible aircraft. Then you have to specify solution 1, and then you have to use assign FEM equals command to import the structured finite element solution. And meanwhile, then you have to have a FLEXLD Bogota card in the Bogota card section. And if the case control command FLEXLD equals 100, then the ID of the FLEXLD Bogota card must have ID equals 100. Echo, you have three options, and if it's none, then ZONAIR will not print out the input file in the output file. If you say sort, ZONAIR will print out the input file by sorting the input file by following the alphabetic order. If you say no sort, and you will print out the input file without sorting the input cards. GENBASE generates an error dynamic database, and by referring to a GENBASE Bogota card. So you say GENBASE equal to n, and then you have to have a GENBASE Bogota card with ID equals n. GENBASE invokes the GENBASE module to correct the pressure coefficient on the cruise ship to those on the GENBASE, because if you want to replace the ZONAIR computed region CP by the CFD solution, and the CFD model is for the GENBASE, and if you use the GECP module, it will correct the CP on the cruise ship to the GECP. So you have a GECP equal to n, to the n, then you have to have a GECP Bogota card in the Bogota card section. And GECP invokes the GECP module to determine the GECP. And then you say GECP equal to n, then you have to have a GECP Bogota card in the Bogota card section. And label, and you provide additional description of the subcase. So label must be located within each subcase. And then and subcase, you have to have a subcase in the case control section to start a subcase section, assign an ID to the subcase. So you say subcase equal to n. So in the case control section, you can specify many subcases. Within each subcase, you must specify a discipline like AEROGEN, FLEXLD, trim, and thermal, and so on. Subtitle must be within a subcase, okay? And the thermal is to invoke the air heating analysis. So the thermal must be located within each within a subcase. Then you have to have a thermal Bogota cards in the Bogota card sections. A title and provide the title of the overall job. So title must be located outside before the subcase. And trim invoke the static area elastic trim analysis by referring to the ID of the trim card. If you specify solution 1, and then that means you want to include the static area elastic effect in the trim analysis. And then in this case, you have to specify assign FEM equals to import the structured finite element solution. In this case, the trim result is for the flexible aircraft. In the trim module, if you want to compute the inertial load, and you have to import a matrix called MGG. This is a GSAT mass matrix, and you can export this MGG from the finite element solver and import this matrix into ZONAIR using assign matrix equals executive control command. Then ZONAIR will use this MGG times the symmetric mode to give you a matrix called SMGH for the symmetric mode, and this is for the anti-symmetric mode. And then from SMGH and AMGH matrix, ZONAIR can calculate the distributed inertial loads. And this is one example how to output the MGG from the from MSC Nextran using the DMAP alter statement. And in the entire ZONAIR input class, if you specify a $ in the first column, that means this is a command, and ZONAIR will not read this line, and so $ must appear in the first column. Okay, this is the end of section 3.